Hello, welcome to Faces of Truth. My name is Alexander McCauley.
Hi, I'm Megan McCauley.
We're going to be talking about primary water sources today and where they actually come from. We all hear this myth that water is running out. And then our politicians say, well, we don't mean water is running out. We're talking about drinkable water. We need to go back to the hypothesis that our geology is based on. And that is, we are a solid crust. The earth is a solid crust floating on top of a partially fluid mantle with a liquid outer core and a solid inner core. Geologists do not know what this liquid is. Every time they have an extremely good candidate for a magma pocket coming up from the depths of the earth, they drill. And, surprise, surprise, it never comes up magma. It comes up salt water. Every mine, or mines around the earth, they end up shutting down several years into their operation because water floods them out from below.
Mm-hmm.
This includes strip mines. They end up having to pump millions of gallons of water out of these mines to continue operation. And most of this water is fresh water. Anyway, there are two conflicting models of the earth. One is the magma model. We call experts that believe in the magma model, which is a belief, Plutonists.
Okay.
We call those who believe in an earth formed from water Neptunists. And yes.
Why is that? Why do you call him that?
Neptune was the god of water.
Mm-hmm.
And Pluto was the god of fire. So if the earth had a fiery beginning,
Mm-hmm.
if it began life as a molten ball, the persuasion was called Plutonism.
Mm-hmm.
And the other end of the argument was called Neptunism, because that believed that our earth was made of water versus fire. And the more we do research, the more evidence we get that the earth may indeed be majorly made of water,
Mm-hmm.
not fire or melted rock. This gives us a few interesting ideas that we may explore in future episodes of faces of truth.
Okay.
One of them being Hollow Earth. That's going to be fun. But the way that scientists came up with the model that we're standing on a solid Earth outside of a partially liquid environment is earthquakes, seismic waves from earthquakes propagate from the epicenter, and they travel at different speeds through different viscosities of material. If you're traveling through a solid, most waves travel faster through solids. Liquids slow the wave down more as they perpetuate and or propagate, and then gases almost entirely block waves.
Okay.
So this is the way that they find out how our Earth looks inside. A fault slips, produces waves like a vibrating guitar string that propagate through the Earth's various layers, and they take measurements of these waves at seismic stations all around the Earth. And the time that it took the waves to get to the seismic stations indicates approximately what the material those waves propagated through on their way there.
Meaning what they consist of, or?
No, what they had to pass through.
Oh, okay.
What they were actually passing through while they were there. There are some stations that don't pick up the waves at all. These are called shadow zones. There are a lot of them that pick up the waves and in a sort of a distorted way, and by measuring the distortion, they find out exactly what type of material those waves passed through, whether it was a liquid, a solid, or a gas.
Okay.
Now, they found that a lot of the Earth is liquid. They assumed, because lava comes out of volcanoes, that this liquid was molten rock.
Okay.
Well, not so fast. Every time they drill into a quote-unquote good candidate for a magma pocket, they hit salt water, not magma. So where does lava come from?
Good question.
It comes from fault scarps rubbing together, causing frictional heat that melts rock. That melted rock weakens the rock over
Heats.
that lava, and that pressurizes both water that is inside the fault scarp and the lava.
I have a question. Why is it called a fault scarp?
It's because it's more of a plane than it is a line. You see? There's two plates. They've got a certain amount of surface area that meets, and every once in a while they slip or slip, and it rubs.
That sounds like an earthquake.
Yes. Earthquakes are the origin of volcanoes, not the other way around.
Oh.
And earthquakes cause lava to form. They also produce most of the sand that we have worldwide.
Earthquakes.
Earthquakes.
Okay.
You get the equivalent of mountains ground to powder within a few hours in fault scarps.
Mm-hmm.
Anyway, I think we're about done because the point we're trying to make here is that we've got water filling aquifers from below and from above.
So there really is no water shortage.
There is no water shortage because that water coming from below under the influence of the centrifugal force of the earth is percolating through sediments and rock strata, just like the stuff from above that falls as rain. A lot of these aquifers that contain what we call primary water that comes from below are actually drilled to extreme depth rather than shallow, regular wells. Exactly. Jerusalem and many many nations in Africa drill these deep wells to get water, and it's not runoff. It's not collected from rain.
Okay.
It comes from underneath. Mines are literally flooded from the volume of water that comes from underneath the mine. And this is fresh water. We are not running out of water. However, we do need to figure out more efficient ways
to use it,
to filter it so that we can drink it. However, there are people who are working on filtering it through plants, which can actually consume minerals that we can't.
That could actually be the subject for our next Faces of Truth, because that's really interesting, but we're out of time.
If you like this, please like, subscribe, and if you didn't like, you can, or if you did like, comment.
Please leave if you have any subjects that you would like us to discuss, leave it in the comments below, and we'd love to take your comments and run.
Also, please share this video. A lot of people don't know about primary water and the ways that, or the theory behind it. So we need to get this out there. Thank you.
Thank you. Bye.
See you next week.